All right. So our next presenter is Audrey Barker Plotkin. She is Senior Scientist and Site Manager at Harvard Forest and Director of the Harvard Forest Summer Research Program in Ecology. Her research delves into long-term forest development, especially how forests respond to disturbances such as wind and insect outbreaks. She has a BA in biology from Carleton College and an MS in forestry from the University of Maine, where she focused on forest ecology and silviculture. She is pursuing a PhD in environmental conservation in the Spatial Ecology Lab at the University of Massachusetts. She's also involved in land management as a Massachusetts licensed forester. Audrey is going to be talking to us today about the Harvard Pisgah Tract, a century of forest research in 20 minutes. So go.
Short people. Okay. Thanks, everybody. Yeah, thanks, Catherine. I'm going to be talking about the Harvard Pisgah Tract today. So the Harvard Forest is mainly in central Massachusetts. We have about 4,000 acres, but in the middle of Pisgah State Park, we own about 20 acres of never logged forest. And I'm here to tell you some of the lessons we've learned over the past century. And this is the work of a lot of people, but I'm going to be highlighting work from David Foster, who's the former director of the Harvard Forest, Emma Sass, and Tony D'Amato. And I've had the absolute privilege of working at the Pisgah Tract for about 20 years. So just to set the stage, you're all here, you know that the destinies of humans and the land are deeply intertwined. There's been millennia of indigenous presence on this landscape that continues. There was a huge change in the relationship between humans and the land with European settlement, where there was a giant transformation by clear-cutting most of the forest and a lot of land conversion to agriculture. So, these magnificent, large pine hemlock forests, there weren't very many left by the 1800s, but there was about 300 hectares left in this Monadnock Pisgah region. And that drew a lot of people to come, check out these giant trees. And that included Richard Fisher, who was the first director of the Harvard Forest. He founded the, forestry was a new progressive profession around 1900, and everyone wanted to start a forestry school. So Richard Fisher was brought in to start the forestry school at Harvard University. He was an early advocate that forest management must be guided by a deep understanding of natural and cultural processes. So basically, how can forest management emulate natural processes? And to learn that, you need to have some reference forests where you get to see how things unfold without human intervention. So just to, at that time, the New England Box Company was the major landowner in this region. They owned about 5,000 acres. And in 1919, they announced plans to log the remaining old growth in hemlock. So this spurred a small fundraising campaign to preserve a piece of this. And that's how Harvard University ended up owning this little 20-acre piece in what's now Pisgah State Park. Most of that area was logged, subsequently. And Fisher had three master's students, Branch, Daly, and Lottie, who worked together from 1928 to 1930 to survey the remaining old growth and kind of follow the loggers around to, look at the stumps of the trees that had recently been cut. So just to give you a little orientation, there we go. Here's Pisgah Reservoir. Here's North Round Pond. A lot of the remaining forest that hadn't been cut, in that 1928 time was up just south of North Round Pond that you can visit in Pisgah State Park. And there was also these these plots that they called the stump plots. And what they did was really reconstruct the history of, how did these forests develop over time? By taking increment cores of the trees, laying pieces of paper on the freshly cut stumps and marking, 10-year growth increments. And they also looked for evidence of disturbances by looking for things like fire scars on trees. And, when there's a tip-up mound, seeing how old is the tree growing on that tip-up mound to get a sense of when that wind event happened. So, the prevailing paradigm was, and in many circles still is, that old growth forest dynamics are driven by really small scale single tree gaps, like the one this guy is sitting on. And these students found that, yes, there were long periods of time where small gaps, very minimal disturbance was the rule, but this was punctuated by periodic large disturbances that drive forest dynamics kind of at a larger scale. And much of that evidence came from examining the ages of trees in their plots. So this is a paper from the 1980s that David Foster compiled, this master's thesis work along with a lot of other work. It's a cool paper. And put together this kind of chronology of when did the trees in this forest establish. So very cool. Oldest trees established prior to 1500, at least one. But really, if you were thinking that single tree gaps was the rule, you'd expect to see, pretty even establishment of trees over time, but that's not what they found. They found distinct pulses of trees, especially a really large pulse of disturbance in the later 1600s. There was a major hurricane in the area. There's historical documentation of this in 1635. And then there was a fire. They found fire scar evidence and historical accounts of a fire in 1665. And that's where most of the big pines and hemlocks established. So the black bars are hemlocks, the white bars are pines, and based on, these are the years they established. Since that big, disturbance in the region in the 1600s, there were some smaller pulses of tree establishment from smaller events. This is S for a windstorm. They don't know what happened here. Fire, smaller hurricanes. And that's when you get some of the other species that you find throughout the forest, notably chestnut, which obviously you do not find anymore. But there is the Chestnut Hill Trail in Pisgah State Park, so it used to be there. American beech, really shade tolerant species, and in some of the bigger gaps, probably some red oak. But really, it was those pines and hemlocks that really ruled the day. So Branch, Daly, and Lottie completed their work in 1930, and Richard Fisher died in 1932. And I always wonder, based on what they discovered, might they have guessed that the next major disturbance was just around the corner? And that, of course, was the great 1938 hurricane. Region-wide, we lost 70% of the standing timber. And at Pisgah, 3/4 of the area was moderately or severely damaged, including most of that remnant old growth forest in the Harvard Tract and at North Round Pond. So this shows what it looked like in 1942, just after the hurricane. And I don't even know. Can you imagine crawling through all of that debris for that photo shoot? Yeah. So what happened next? Well, most of the area, including the remnant old growth forest around North Round Pond, was part of a massive federally coordinated timber salvage effort and cleanup program. However, the Pisgah Tract, the Harvard-owned 20 acres, remained. So this is a photo of Al Klein, who was the director at the time. He overall supported the salvage effort, but really stood by the the mission and purpose of the Harvard Pisgah Tract as this reference forest and refused to allow salvage harvesting there. So that's lucky for us because now we can learn about the legacies from this massive disturbance. So we're going to fast forward 45 years. So going from, just after the hurricane to at least 50 years later. Harvard Forest had some quiet times with not doing a lot of research at the Pisgah Tract. There's a couple notable exceptions. There's an awesome paper from the 1960s that really outlines how to do forest reconstruction work. But it wasn't until David Foster arrived in 1983 that research picked up again. And, so he was very eager to go up there. And what he found was that, these old giant pines and hemlocks were still there. They were just lying on the ground. And one of the things that you can look at is, say, look at, this is definitely from that 1938 hurricane. Most of the down trees were uprooted. And most of them were oriented in that northwesterly direction of the strongest winds. So, in 1984, about 45 years after the hurricane, the Harvard Tract, really, there were very few pines that were still standing that predated the hurricane, and most of those were snags. There were only 10 standing dead trees across that 20 acres, but they were still gave a taste of what it must have looked like. They were 30 to 50 inches in diameter and more than 100 feet tall. And there were also these massive amounts of down dead wood and tip-up mounds. So I'm a little bit obsessed with tip-up mounds. So I'm going to tell you a little bit about them. The size of the huge trees mean larger and more persistent tip-up mounds. So 50 years after that 1938 hurricane, here's at Pisgah, there were still some mounds that were more than a meter tall. And that's in contrast to another study that I work on, which is a simulated hurricane experiment that was created in a second growth mixed hardwood forest. And although after that, we had lots of tip-up mounds taller than a meter, none of them persisted more than 20 years. So you really need big trees to make big tip-up mounds. So, we've heard a lot about forest structure, carbon stocks, how those all intertwine. So I'll just tell you a little bit about what we know about, what were the carbon stores before and after the hurricane. And for that, I'm turning to a study that was done by a doctoral student, Peter Schoonmaker, in the 1980s. So 50 years after the hurricane, he set up a couple of transects that go across the elevation gradient of the tract. So there's 57 of these little plots that are 10 by 10 meters with these detailed sketches showing everything, like the tip-up mounds, the down trees, the little circles are the living trees, in 1989. And Tony D'Amato took those maps and reconstructed the pre-1938 biomass, from the down wood measurements from 1989. So probably missing anything that had decayed within that first 50 years, but even so, when he tallied it up, found an average of more than 350 metric tons per hectare of live tree biomass, which is among the highest amounts found in New England forests. To put that into context, the live tree biomass on the Harvard Pisgah Tract now is less than half of that, only about 150 metric tons per hectare. And the second growth forests, hardwood forests and Harvard forests, and I think some of the data that Matt was showing, shows something more like 250. So well above the average. And that's really driven by those giant white pines. We had a couple of summer students there's Brendan and Maggie came back 20 years later in 2009. And what they found, they remeasured the down dead wood and live tree growth. They found that in that 20 years, many of those down dead wood pieces had decayed into soil by then. But the ones that remained tended to be white pine. They seem to be very rot resistant. So although white pine is no longer part of the forest canopy, it still, persists in structuring that forest floor and forest structure. And it also, pines like this, there's still a substantial store of carbon in that dead biomass because they're taking a very long time to decay. It's about 50 metric tons per hectare. In addition, the tip-up mounds and downwood add structural diversity to the forest, and that in turn enhances tree diversity. This is something that Emma Sass found. She was one of Tony's students. She analyzed the structural diversity in each of these 10 by 10 plots and found that that was associated with higher tree diversity. Thanks. And I looked at that in more depth, looking at what trees are growing on tip-up mounds, what trees are growing in the pits, as well as sites for tree regeneration. And I found that everyone likes growing on mounds. No one likes growing in pits, but it's really black birch and paper birch that really strongly prefer these mounds. And that's really important in a forest like Pisgah, where, before the 38 hurricane, it was very, very shaded, dense canopy. And it was really only these very late successional species like hemlock that were able to be saplings to respond after the disturbance. So the mounds were really an important place for diversifying that forest composition. I'll also note that you can see that it's everyone wants to grow on the mound, but it's kind of risky. And I did find that trees growing on mounds had a much higher mortality rate from 1989 to 2009 than those growing on the ground. Another thing Emma did was look at how do the fates of the stump plots, the ones that were harvested, the ones that were old growth but were salvaged after the 1938 hurricane, and then compared to the unsalvaged site. How do those fates differ over time? And she found that the forest composition was very similar she did this in 2016 by then, but that the structural diversity, especially with the downwood and the tip-up mounds, were very persistent differences among those things. And I just, one of the things that you can see in the unsalvaged area are these bent trees that were really small at the 1938 hurricane. So they didn't die, but they've got this crick. And then, just to point out that this is, in 2016. So this is like, I don't know, more than 75 years after cutting. Some of these stumps are still massive. So what are we doing in the Pisgah Tract now? We have a suite of permanent plots that we census every 5 years. And for the most part, the forest continues to grow and change really slowly. It's not the most interesting phase of its life, but it's good to keep track. However, there are, we do have some gaps. That's me. Yeah. Trying to measure down dead wood in one of our plots where we had a lot of wind-thrown hemlocks. We think that they died from armillaria root infection. And thinking about, changes on the horizon, 2 of the major trees, hemlock and beech, are threatened with non-native pests and diseases. So beech bark disease is rampant throughout the Pisgah State Forest or State Park. That doesn't kill the beech trees, but beech leaf disease could. And then I've seen hemlock woolly adelgid in the Harvard Tract. The trees are still doing okay, but I imagine, especially with warming winters, that will they'll start to decline in the next 10 years. So I don't know, what's going to happen if we lose those species? Maybe there'll be enough growing space opened up that we'll get some white pine regenerating. We'll definitely get black birch. I know that. So, whatever the future holds, the Harvard Pisgah Tract is going to remain this steadfast reference site just to witness how forests change over time without human intervention. So thanks very much, and acknowledge lots of people who've worked on this and funding.
We do have some time for questions, and just to remind the people on Zoom, type your questions into the chat if you have questions.
Yeah.
Is there any surviving standing old growth in the central Mass tract, the Harvard Tract?
The Harvard Fort, no, there is not. There are some remnant old growth sites in Western Massachusetts, however, that Tony D'Amato has studied. Yeah. Yeah, pretty much, there are areas that were never cleared for agriculture, but they were all, cut over for wood use.
Keep talking.
Oh, okay. Yes.
Could you elaborate on why the tip-up mounds are so attractive? And then how do you think about the fact that the mortality is higher? So it almost seems like a misguided.
I know, it is kind of sad, isn't it? I think that on balance that it's still, it's still worth it because not all of them die. I've seen, the root systems of these birches can, start here and really anchor themselves in the ground. So it's not like you're for sure going to die. So I think that the reason why they're so preferred is that, it's some exposed mineral soil. So if you think about, a hurricane disturbance it affects the canopy a lot, but it doesn't affect the ground except where you have, this soil disturbance where trees uproot. And that's really important. A lot of trees need that mineral soil to regenerate. And then it also, if you're starting this tall already, that's a huge advantage. Yeah.
Isn't it also true you have to grow where you're planted?
Yes.
So the seed falls.
Well, for sure. So it's not so much, it's not so much that the seeds fall on top of the mounds more, but that they survive, that crucial, like most of the seeds that germinate don't make it past the first year. So yeah. Great. Thank you.